All right. In this set of notes, we're again going to be looking at basic geometric objects. Here, we're going to ask, how can two lines, rays, or segments be oriented in space relative to each other? Now, kind of confusing sounding, I suppose, but what we mean is we got two lines or two rays or a line and a ray or a line and a segment or whatever, and they're just kind of floating out there in space somewhere. How can they be arranged? There's three basic ways that they can be arranged. And we're going to look at how they're going to be arranged. We're going to look at hold on. Okay, anyways, I'll look at how and an example with notation. Okay, so first, the well-known one is parallel. Now, specifically, parallel means they're in the same plane. And they don't intersect. Or wouldn't intersect if extended forever. Because we might be talking about a pair of, say, segments, and just because they don't cross doesn't mean that they are parallel. They could be, they just don't reach each other. All right, so take a look at our example here. Okay, here's a line. We'll call this line, we got AB. And then we got down here, we've got line CD. And to show that they're parallel in the diagram, we would draw little arrows. And sometimes it's one little arrow, sometimes it's two little arrows. Arrows on the diagram show that they're parallel. And we would write AB with our line over it, okay, is parallel to CD, like that. On the other hand, here's another example of a couple of segments. And we can call this M, N, P, Q. Now they don't touch, but if we were to extend both of them forever, they would cross. So we would write MN. We would cross off the parallel PQ. And notice these are segments, so I have not put any arrows over their headings. Alright. Next, we have, and here's another common one, perpendicular. Okay. So here, the lines intersect at right angles. So here we could have we got something like, I don't know, this is A, B, C, and we would say, this is our right angle symbol. And we would say that AB, line AB, double-headed arrow there. And we use this upside down T, AC. Okay. So perpendicular to. Alright, last is the one that we tend to forget about, which is skew. And skew are lines that don't intersect. So just like parallel lines that don't intersect, but not in the same plane. So here, and there's no particular notation for skew, you think about like a box, a room perhaps, rectangular, kind of a rectangular prism like this. Okay. If we call this back corner, okay. If we call this back corner, say A, we'll call this over here B, we'll call this C and this D, we would say that CD, and I could put my, technically we would probably want to talk more about lines. So I'll extend these, make them into lines. Okay. Line CD and line AB are skew. Okay. So they don't cross. The back top edge of the box and the front left edge of the box, if we were to extend them forever, they never cross, but they're not in the same plane, so they're not parallel like railroad tracks are parallel. So just because two lines don't intersect, and here's a common trick question, just because two lines don't intersect doesn't mean that they're parallel. You have to say they don't intersect and they're in the same plane, because if you don't say that they're in the same plane, then they're skew. At least they could be. Okay. All right, looks good.